Video ended with question 4, so this one picks up with question 5. We're asked to write the equation in slope-intercept form of the line tangent to the function negative x squared plus 4x at the point 3, f of 3. So to do this, we're going to need the slope and the y-intercept. Here I've started with a slope, and to do that, to find that, we're going to need the derivative. And so once again, we just use the power rule. It's a polynomial, so we can use the power rule on each term. We bring the 2 around front of the negative x squared, so that becomes negative 2x, because 2 minus 1 is 1, and next to the first is just x, so that's the first term. The second term is a linear term, 4x, and so when we have a coefficient times just x, then we just, that differentiates to the coefficient, which in this case is just positive 4, so there we have our derivative, negative 2x plus 4. To find the slope at that of the line tangent to that point, then we substitute the x value we're given, 3, into the derivative. We evaluate the derivative function at 3. So wherever we have an x, we have parentheses. Inside those parentheses, we put the number we're evaluating the function at, and so that's negative 2 times 3, which is negative 6, plus 4 is negative 2, so that's our slope. Now we need the y-intercept, and to do that, we will solve, or to find that, we will solve the equation y equals mx plus b, and so to do that, we need a y value. We need a function value. We have the value of x, which is 3, and we have the value of the slope, the m, which is negative 2. We need to know what this y value is, and so we evaluate the function at 3. Not the derivative, but the function x squared plus 4x. So f of 3 means that wherever we have an x, we put a set of parentheses, and inside the parentheses we insert the 3. 3 squared is 9, but it's negative 9 because this negative is outside the square, and 4 times 3 is 12. Negative 9 plus 12 is 3, so that's our y value at that point. So then we substitute the y, which is 3, into the equation y equals mx plus b. And so we have 3 equals negative 2 times 3. Negative 2 times 3 is negative 6. And when we add 3 to both sides of this equation, we have 9 is equal to b. So our equation is y equals negative 2, because we discovered the slope up here, x plus 9, the y-intercept here. Now, question 6 asks us to differentiate f of z, capital F of z, and we have we have a radical in the first term, and in the second term we have our variable z raised to the power 6, but it's in the denominator. So in order to differentiate this, the easiest way is to use the power rule after converting this rational exponent and this exponent in the denominator or rather this root into a rational exponent and this exponent in the denominator into a negative exponent. Sorry. And so that gives us 3 times z to the 1/3 right here, minus 1 over 6, the 6 stays down here in the denominator, times z to the negative 6, because z to the negative 6 is the same thing as z to the positive 6 in the denominator. So then we multiply the 1/3 around front and subtract a 1 for the first term, and then we bring the negative 6 around front and multiply it times the negative 1/6. So 6 times 1/6, that's just 1, and since they're both negatives, it's a positive 1, and so this just becomes plus z to the negative 6 minus 1, which is z to the negative 7. Here, 1/3 times 3 is 1, and 1/3 minus 1 is negative 2/3. To put these in positive exponents, we simply bring the z to the negative 2/3 down to the denominator. So this is z to the positive 2/3. We bring this z down to the denominator, and that's z to the positive 1 over z to the positive 7. Now, you don't have to write this in radical notation, but if you did, that's the way you would do it. The denominator of a rational function is always the root, and the numerator of, or not a rational function, but a rational exponent, and the numerator of a rational exponent stays inside the radical. Okay, now the next question, question 7, asks us to determine the marginal revenue at a particular value of x, and when you hear marginal, think derivative. So we have a revenue function, and we use the power rule to find its derivative. 20x is a linear term. It's just an x term, so that differentiates to just the coefficient. And then x squared over 50 is the same thing as 1 over 50 times x squared. That means that we would bring the 2 around front, and 2 over 50 is 1 over 25. So when we bring the 2 around front here, that 2 cancels with the 2 that's in this denominator. 25 times 2 is the way that would factor, and that 2 would cancel with the 2 in the denominator. 2 minus 1 is 1, and so our marginal revenue function is 20 minus x over 25. Now, on the question on the test, the function will be of this same general form. It will look a lot like this, just the numbers will be different, but everything else will be the same. So our marginal revenue is 20 minus x over 25. We're asked to find the marginal revenue at a production level, which is what this x is, of 450. And so we evaluate that derivative at 450, which means that wherever we've got an x, we put some parentheses, and inside those parentheses we put the 450. 450 divided by 25 is 18, so we subtract 18 from 25, and that gives us 2. 2 is the marginal revenue at x equals 450 units. Now, we are asked to interpret this result. This is the interpretation. At a production level of 450 units, our revenue is increasing at the rate of $2 per unit produced. That's what this 2 means. That is the rate at which our revenue is increasing. Why is it increasing? It's increasing because this is a positive value. When we do everything that we just did for a production level of 550 instead of 450, then we will have a negative 2. And everything is the same, except now the revenue is decreasing at the rate of $2 per unit produced. Why decreasing? Because this is negative. So positive means an increase, the rate is increasing. A negative means that the rate is decreasing.